Welcome back, friends. Um, Now let us just deal with the, the bicyclic system, the nomenclature of bicyclic system, right? So in my first video, that means the part one of this nomenclature of bicyclic system, you might have gone through that the way by which the bicyclic system can be named and all, right? But till date we are done with this the naming of a bicyclic system which is exclusively made up of hydrocarbon, right? And that time only we told that in my next video definitely I'll come up with some examples in which the heteroatoms are inserted in the bicyclic system, right? So let us just deal with the topic or deal with that particular thing, okay, right now. So the thing is that as I said that some rules are followed, right, as we have seen in case of bicyclic system, especially the how the naming will be done. First and foremost, you have to start up the process with a bicyclo, and then in the third parenthesis you have to put the number of points, right, and it should follow the from highest to lowest. That means it should be in a descending order, right, and there you have to bring what the longest route followed by the smallest route and followed by the variance, right? Okay, and now after that you have to put the name of the hydrocarbon, right, and it is the name that indicates the number of atoms, right, with which the total system is constituted, right? Okay, or number of atoms which constitute the total system, right? Now let us move to the bicyclic system which are holding an heteroatom, right? Okay, so now let us see that is there any additional thing that need to be incorporated? Yes, we have to incorporate some additional thing, right? Now before that, let me just draw a bicyclic system first. So assume that this is found to be the bicyclic system, and here we have a nitrogen, right? Okay, nitrogen, and we know that nitrogen is found to be a trivalent one, so let us put one hydrogen here. Now say the thing is that now first and foremost you have to count the total number. Though the bicyclic system comprised of a heteroatom, but in the process of naming the hydrocarbon, we have to consider it as a hydrocarbon, and likewise we have to frame the name, right? Whether it is having all carbon or most of them are found to be carbon and few are there which are found to be heteroatom. It's not like that. You have to include the heteroatom while naming the hydrocarbon and while naming the alkanes, right, or cycloalkanes, right? So that means count the number, how many are there, how many points are there, like 1, let's say for example, okay, 1 2 3 4 5 6 and 7 means heptane. Don't get confused. As nitrogen is there, instead of heptane you are not supposed to call it as hexane. As I said, that whether the heteroatom is present or not, irrespective of the presence of heteroatom, okay, you have to, while framing the name of the hydrocarbon, include the presence of heteroatom in it. Consider the heteroatom as the homologous series of hydrocarbon. Got my point? So that is why in the process of including the nitrogen, we are done with the total counting, and it appears to be 7. So 7 means hexane. Hexane? No, heptane. Right, heptane. So heptane should be kept at last, right? It is a bicyclic system. So if it is a bicyclic system, that means the process should begin with the bicyclo. And in between this, we have to put one third parenthesis. That means something should be kept within third bracket, right? Okay. What should be kept? The composition of each and every point. And in the process of counting, in the process of putting the number, you have to ignore the presence of this bridgehead. You should exclude the number of bridgeheads, right? It should be excluded. Okay. So if we just try to figure out which is found to be the longest chain, here both are found to be similar. So that means consider this as A, this as B. Both are found to be similar. They are made up of similar atoms or similar points. That means while counting the number of points, so this is found to be the common point, this one and this one, they are found to be the common point, CP. This is the chain, this is another chain, and this is found to be the variance. That means the bridge. And here the bridge is made up of what? The hydroatom, right? We'll come to it later. So once I told that, if you find that the connector or the chains are comprised of the similar number of atoms, then it's your choice. You can consider this as you can put the number of this particular chain at first, or it can be vice versa, right? Like that. So here how many points are there? 1 and 2. Likewise 2, dot, because a full period, the first number, after the first number you have to put a full period, that means full stop, and then the second number. Okay. So after putting the first number, it is followed by the full period and then the next number. The next number is, it comprises of how many atoms? 2. So likewise 2. Now coming to this variance, how many are there? Only 1. That too a nitrogen. Okay, chalo. Now a question may rise, shall we end up the process here only, like bicyclo 2,2,1 heptane? Then how we can figure out, how we can distinguish as bicycloheptane, which comprised of all carbon, and a bicycloheptane which is of this sort? How they can be distinguished, how they can be differentiated? That means you need to mention what? The position of the heteroatom. Not only the position but also the pattern. Where exactly it is placed? 1, 1. You have to count the number, start the numbering from here. One of the bridges. 1, 2, 3, 4, 5, 6 and 7. So likewise, where it is placed? The heteroatoms at 7th position. So that means you have to begin the process not with the bicyclo. As this bicyclic system comprised of a heteroatom, that means you have to initiate the process with the number followed by the pattern of heteroatom, because I have kept a nitrogen. Somebody has just replaced the nitrogen with oxygen. Somebody can replace with even sulfur also. Okay, all are found to be heteroatom. So in each and every case, we are not supposed to put the same name and all, right? Like nitrogen is aza, like oxygen is oxa, like sulfur is thia, like that. It keep changes, right? So 7. What is that 7? 7 is 7 comprised of aza. So 7 aza, then 7 aza followed by bicyclo 2,2,1 heptane. So this is how it stands. So that means, what is the additional thing that you need to incorporate here? The heteroatom, the pattern, the type of heteroatom that the bicyclic system is holding, and the position where exactly it is located with respect to the whole system. Not with respect to the bridge, rather the whole system. I can get the number while starting the numbering from this zone, and finally I came here. And while reaching here, I came to know that this is the nitrogen which is placed at 7th position. Right? So this is how it goes. 7 as a bicyclo, in third parenthesis 2,2,1 heptane. Right? And don't forget, this should not be, it should be full stop. It should not be a comma, right? Full period, no partial period or half period, right? Chalo. So with that, we are done with what? The nomenclature of heterocyclic or heterobicyclic system, right? So now this is about heterobicyclic system. Now let's just begin spirocyclic. Once we are done with each and every class, then we'll move to the application, or then we'll take few problems and all, so that while dealing with the problem, at least we can strengthen our understanding, right? Okay, as I said earlier. So now spirocyclic. What is the spirocyclic? So here, neither you can find any adjacency or bond, nor you can find any bridge. So here simply, two cyclic system, they are passing through a common atom. Okay, that means when two cyclic system, they are sharing a common atom, that particular system is called as spirocyclic system, right? Okay. So how it goes? Suppose ki, okay. So this is an example of a spiro compound. Here, what I did exactly, I have just merged two systems. One is of 6 carbon, the other one is of 5 carbon, right? These two systems, both the rings, they are passing through a common point. So here the Cp is found to be 1. The common point is found to be 1. But in the earlier cases, the common point were found to be multiple. Points were found to be multiple, right? So in spiro compound, basically the common point is found to be 1. Now, how it goes? Definitely here also you have to bring what? Here you have to put the number of points that each and every branch or connector, okay, or chain, okay, comprised of. And that too, same thing in a third parenthesis, right? But here, the order is found to be exactly opposite. Order means, in the case of fuse system, or we can say bridge system, what we followed, the order was found to be from the big to the small. Big to small. Largest to the smallest. Like 4, 3, 2, 1. That means in a descending order, right? But in case of spiro compounds, in case of spirocyclic compounds, it is just opposite. 1, 2, 3, 4 in an ascending way. In an ascending way. The best trick is to just memorize that which is what or what is just bring your this things bicyclic system, right? Okay, bicyclic system, and that too a bridged one, right? BRIDGED, bridged one. So here we'll just take the alphabet B, and here we'll just take the alphabet S, right? B for big, S for small. For bicyclic system, in the third parenthesis, the big should come first. For spirocyclic compound, as we have kept here S, that means S for small, that means the small should come first, right? So this is the best trick, just to make you aware that what is what. Otherwise, you may be in a mess. That shall we just follow this order or this order in spirocyclic? Spiro starts with S, that means small. That means you have to initiate the process, the number of points which is there in each and every branch, right? Each and every chain, okay? That should start with the small one, right? The smaller one, then to the larger one, right? Okay, this is the thing. Now let us see that what should be written here, how the naming can be done for this. So here the common point is 1. As I said that, now you have to differentiate which one is found to be the smaller. So it's pretty clear to us that this is it comprised of 6 atoms, it comprised of 7 atoms, 5 atoms, right? If that is the case, as I said that in the third parenthesis you have to begin the process with the smaller one. So this is found to be the smaller one compared to this is smaller one, right? So that means you have to initiate the process from here. So count the number of this atom. So here also you have to ignore this one. In both the cases, while counting the number of points present in each and every side chain or each and every chain, right? Always remove this one from the counting. Don't count this one or exclude this one from the counting. In any case, be it in the spirocyclic compound or bicyclic system, in both the cases, we have to ignore the presence of what? The presence of the common things or common points, right? Okay, chalo. So if that is the case, how many are there? 1, 2, 3 and 4. What about this? 1, 2, 3, 4, 5. That means in the third parenthesis, what should be written? Here we have got 5 points, here we have got 4 points, right? So if that is the case, shall we go like this? 5.4 or just ulta 4.5. Why? Because it is the S that will direct us, that will rectify our mistake. Actually, I was in mistake. 5.4, it's not 5.4. It is the spiro. That tells me, yes, no, you were at fault. It should be in 4.5. So that means you are supposed to write what? 4.5. Okay, in the parenthesis. What is the other thing that should be written here? Okay, same thing. As it is made up of hydrocarbon, that means you have to count the total number. It is the total number that will tell you about that will guide you to get the name of the cycloalkane, right? To get the name of that particular alkane. And it is the name that in turn indicates the number of atoms it comprised with, right? It comprised of rather. Now, so now here same thing. So here how many are there? Total here 6, 7, 8, 9, 10. 10 are there. So total 10. 10 means decane. 10 means decane, right? So before that, what should be written? You have to put the parenthesis, that is 4.5. And before that, simply spiro. So basically this is spiro 4,5 decane. That's all. So this is how it goes. There is no bicyclo. Why? In case of bicyclic system, 2 cycles, there was the pattern was found to be different. The pattern was found to be adjacency existing. Okay, there was an adjacency, right? But there is no adjacency here. There is neither adjacency nor non-adjacency, right? Only thing is that if 2 cycles they are sharing a common atom, that time this is called a spiro. That means the spiro has to be indicated first. That means you have to initiate the process with spiro, right? Okay. Now this is the case. So now let us move to the next one. Okay. Now let us move to the next one. The next thing, that means if a spirocyclic compound possesses a heteroatom, what should be followed? What should be the way of naming? Okay, let's find. The same thing. Let us bring the same thing, right? Let us bring the same thing, right? Here. Like this, right? How it goes then? How it goes? The same thing here also. Everything will remain same. Only thing is that you have to initiate the process with the position. The position and the pattern. That should be mentioned at the very beginning of the naming, right? Okay. So that means what is that? Now here, the overall numbering. How this can be done? The overall numbering. I forgot to tell you. Okay. As I told you that you have to, in the third parenthesis, you have to start the process with the smaller one. So that means here, it is the small cycle or the smaller one will get the priority. So that means immediate next to this common point, you have to put the position 1. That means it is the position 1, that is nothing but immediate next to this common point. It's not that we have to start the process from here as we did in case of bicyclic system. In bicyclic system, what we did basically, we have taken either of the bridge as position 1. But in this case, it is found to be different. Okay. In this case, it is found to be different. In this case, what exactly we are following? We are just keeping this aside. Okay. We are ignoring this one, right? Immediate next to this common point, that means the spiral linkage, the ring which is found to be the smaller one, okay, should get the position or should get the first locant number. So that means how it goes? 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So with that we are done with what? With that we are done with the name of the cycloalkane, name of the alkane, okay? And that time only I told that whether nitrogen is present or absent, इससे कुछ बदलने वाला नहीं है, right? That means the name of the alkane will not depend on whether it possesses a heteroatom, single heteroatom or a multiple heteroatom. Each and every heteroatom has to be considered as a carbon only. And likewise the name goes not no name, rather spirodecane. Why? Because the last locant number is found to be 10. And that is why it is basically what it should be written, spiro. How many are there? That means here 4, number of points. Here 4, here 5. So this is 4.5, small to big, right? Small to big, lowest to highest, right? Why? Because spiro will guide us, right? Spirodecane, right? Spirodecane. And before that, what should be put? We have got the number and we have got the pattern. So that means at the very beginning only you have to put what? 8 as a spirodecane. Let me tell you one thing. Okay, as I have brought these things, okay. This is the system which is there in a muscle relaxant actually. It is there in a muscle relaxant, at the same time anti-anxiety drug. Okay, the name of the drug is buspirone. See, if we just focus, if you just put your focus in the name itself suggests that buspirone contains what? A spirone system. That means spiroone. That means how it should be? It should be like this. So this is the system which is there in an anti-anxiety drug called buspirone. And in the name itself, within the name only you will find the existence of spiro. Spiro, not only spiro, the additional information is one. That means carbonyl group. And carbonyl is found to be placed within the spiro system only. And bus for butyl, immediate next to this nitrogen, a butyl system is there. That means a chain of 4 carbon is there, right? And after that we have 2 heterocycles like there, that is piperazine, at the same time pyrimidine, right? So this is the basic skeleton of what? Buspirone, right? Buspirone. But we are least concerned about the entire structure of buspirone. Just for your understanding, for your information, let me tell you why it is important. Though they are telling that spiro is found to be very rarest of rare cases, they are bringing spiro system and all. But let me tell you, this is the drug which is still available, still there in the market, right? So that means we should not ignore the contribution or the presence or the existence of what? The spiro compound, right? So it is found to be a living example, what I should say. This is a living example, right? See, this is the system, but just derivatizing the system in such a way, decorate the system in such a way that it will become buspirone. So this is the system that is present in an anti-anxiety, that is buspirone, right? This is found to be the application of the spiro compound, right? Now, now let us deal with few problems. Okay, now let me bring a few applications, right? Applications of this bicyclic system or the nomenclature, which we are dealing with, okay, in our mundane, study and all. Okay, now coming to this bicyclic system, we have a, have a compound that is called atropine, right? Atropine. So atropine is a drug, it's a naturally obtained drug actually. Atropine possesses a bicyclic system in it, and that too a heterobicyclic system in it, right? Atropine. Now it is an alkaloid, and basically it is acting as a cholinergic blocker, right? It's an autonomic drug, and the purpose is to antagonize the functioning profile of autonomic nervous system, especially the parasympathetic branch, right? Okay, so atropine basically will focus on the system which is having a resemblance with the bicyclic system, right? In case of atropine, we have a nucleus called like this. We have a bicyclic system which is something like this. Something like this, right? Okay, so this is the portion which is called as tropine portion. So as a whole, this is called tropine. If we just put one tropic acid here, like your HO, C double bond O, CH, CH2, OH, and then followed by a phenyl, merge them all together, what will be there? Merge them all together, there is a formation of what? There is a formation of atropine. So this is how this can be made actually. But we are least concerned about this. We are concerned about this because we are just trying to see that after going through this rules and all, or the kind of things that should be followed while naming the bicyclic system, where exactly it is applied actually. And for that only I have brought this kind of examples, right? Okay. So here it is the bicyclic system, and the example is the bridged bicyclic system, right? That means there is no non-adjacency. Non-adjacency exists. Okay. So now we have to see there are two bridgeheads. First and foremost, you have to locate the bridgeheads. Okay, bridgeheads. We are done with the bridgeheads. Then we have to see that which is found to be the largest chain. The largest chain is definitely, it's pretty clear to us. 1, 2, 3. It's comprised of 3 atoms, 3 points to atom. So we have 3 points here. These are found to be the CP, that is common points, right? And in each and every counting, you have to exclude the number of common points, right? So that means there is no question of making it 3 plus 2 equals to 5. That is, it will always remain as 3, right? So this is 3. Coming to this branch, that is the smallest branch, it comprised of 2, and it should follow a descending order. Descending order, why? Because it's a bicyclic bridge system. B for big. Big we have kept first, then followed by the smallest one, and after that the variance. Variance comprised of 1 atom. So put 1 here, put 1 here. Now the one which should be kept in third parenthesis, we are done with that. Next is, as it is as heterobicyclic system, that means the position of the nitrogen has to be mentioned, right? So likewise we have to start the numbering from here, like 1, 2, 3, 4, 5, 6, 7, and this one is 8. So 8 means irrespective of whether nitrogen heteroatom is there or not, you have to consider the heteroatom as a hydrocarbon while framing the name of the alkane. As it comprised of 8 atoms, that means it's octane. So put octane here, and before octane the bicyclo. चलो bicyclo ये भी डाल दिए. अब क्या करना है? As it is holding a heteroatom, the position at the same time pattern has to be mentioned. So we'll start the process with the position, then followed by pattern. So where exactly it is placed? 8. So 8 as a bicyclo 321 octane. So this is the name. We are least concerned about the one that the 8th nitrogen is holding, right? We are basically concerned about this portion. And that is why the name of it is nothing but 8 as a bicyclo 321 octane. This is the way you should name this one. Got my point? Chalo? Okay. So we are done with this, the nomenclature of this atropine and all. Okay. Let us deal with few more, right? Let us deal with few more. Okay. Let us deal with another anticholinergic, like a bipyridine, right? Bipyridine, yes, if I'm not wrong, bipyridine, and it's an example of a synthetic, anticholinergic, right? Synthetically developed anticholinergic. It also possesses a bicyclic system, and the common name of that particular bicyclic system is found to be norbornane, right? Norbornane. So how the structure will be? Okay. Let us just draw the structure first. Like this. Okay. Okay. So this is the portion that is there. This is the portion that is there in the Norbornen. So as a whole, this is called Norbornen. Now we are less concerned about the Norbornen, right? Better, because we know that how to name a particular bicyclic system. Okay. So that means we just apply our this understanding and all here. So how it goes, and it is the second position which is holding the substituent, or which is linked to a centrally placed carbon. We have another thing here, followed by a hydroxyl here, followed by CH2, and then we have a bipyridine. As a whole, the structure of bipyridine, right? And bipyridine is a drug which is basically used to treat the rigidity, okay, which is associated with a nervous disorder, that is a neurodegenerative disorder, that is Parkinsonism, right? So bipyridine is a drug. Basically, the anticholinergics, they are employed in elevating certain symptoms. They cannot work, or they cannot cure or relieve. They cannot deal with each and every symptoms, because as you know that the Parkinsonism is an umbrella term, right? Anyway, I'm debating from my path, right? Okay, let us just back to business, right? Okay, we'll discuss about Parkinsonism in some other videos and all, right? Okay, now let us deal with this. So this is found to be the bridgeheads. There's two other bridgeheads, right? Okay, that means they are found to be the common points. They are found to be the common points, right? As they are found to be the common points, so that means we have to exclude this one from the numbering, right? Now here and here we have two branches. So both are comprised of two atoms. Both are comprised of two atoms, right? So this is A, this is B, right? In that case, both are. That means in the third parenthesis, what you are supposed to put? 2.2. What about this? 1 only. And as there is no heteroatom, simply bicyclo 2 to 1. Then how many are there? 1, 2, 3, 4, 5, 6, 7. 7 means heptane. Heptane. Is it okay? No. Why not? Because why no? Because double bond is there. Don't forget to put the place to put the double bond here. That means you are not considering it as a heptane. It's not a cycloalkane. It's a cycloalkene. Bicycloalkene. So here hept. The position is 1, 2, 3, 4, 5. Hept 5 in. With that we are done with the naming. As one double bond is there, don't forget to mention the double bond, the position of the double bond, as well as the in, right? So no heptane, hept 5 in. So this is found to be another example, okay? Another example of what? Of this bicyclic system, right? Okay. Now, so now with that we are at the verge of the completion of this session and all, right? In future, definitely I'm planning to come up with the nomenclature of some fused heterocycles, right? Which is another important domain, right? Which has to be cultivated which has to be nurtured in a proper manner, right? In my next video, or I'm planning to materialize this concept and all, okay, definitely. So with that we are done with the nomenclature of this bicyclic system. In future, I am also trying to bring the nomenclature of tricyclic system as well. So with that, let us just put an end to today's discussion. If you really like my video, please don't forget to press the like button, and please do subscribe, so that at least I can update myself. And please leave your comments, your valuable comments, right? Your comments is very much important for me, so that with those comments I can modify myself, I can modify my way of deliverance, I can modify my informations and all. So please, thank you for that. Thank you for the patience here. Thank you.